All right, I don't see anything in the chat room. No questions about that. So this is basically our proper title. So now that we've covered casing, let's look at string comparison. Let's delete all of this stuff out. Now there's one way to do string comparison, of course. Say string 1. This is a string. String 2. This is a string. If we'll just comment out strings for now, since we're just doing a basic match. And as you can see, because there's different title case, there's no match. So this is one really quick, easy way to do a string comparison. It works pretty good. It's pretty fast. It's good enough, basically. So let's use the strings library to do a strings comparison. We can get a little bit more granular with it. So if I keep putting the parentheses, that's one of the problems with spending time in too many languages. Strings compare, string 1, string 2. And it is arguing with me. Compatibility check. Interesting. Non-bool used as an if condition. Oh, that's right. Showing you guys how to use string compare, and I don't even do it properly. So it does not return a bool, returns a 1 or a 0. So now it says we have a match. Of course, if I change it, no match, because it's case insensitive. Or case sensitive. So if you want to make it case insensitive, that's fairly easy. Here's one of the more common ways that I do case insensitive comparisons, using what we just used before. So now we want to see if it's the same string, even though the casing's different. Sure is. But if we change the actual content of the string, we have no match. So this is how you do strings comparison with the strings library. Super easy. Strings compare string 1, string 2. If they're equal to 0, that means you have a match. If they're equal to 1, then you don't have a match. And it does a kind of a strange comparison. Actually, I will show that. We'll just bring up the Golang standard library page. Golang string compare. Pretty interesting. So for the comparison, it does it lexicographically, however you say that. So result 0 means A equals B, -1 if A is less than B, and +1 if A is greater than B. So it's kind of interesting. I've never really used it any other way than just to compare two strings side by side, but you can compare and see if one is greater than the other as far as their characters goes. It's a little interesting. So let's see what else we can do here. Now here's one thing we could do. We could compare and see which one of these takes longer. So I'll import time into here. And I gotta look up something here real quick. I know I found something. I'm not able to find it. So we'll wing it. So we'll do start one equals time dot now. What we'll do is we'll time these guys here. Call this start one. These are two strings. And we'll create a function here. Keep typing function. Time track. And actually I do have this copied, don't I? Somewhere. Oh well. Do our start time, which will be a time.time. And we'll pass in the name so we can keep track of which is which here. And all this is going to do is print out an elapsed time. So elapsed equals time.since start. Printf. Probably going to need to do a value on this, but I'll try a string anyway. Change this back. We'll see how long it takes to we'll time track this with time.now, and we'll call this string compare. Oh. Not time.now. Pass in our start time. Okay, let's see what this shows. Yeah, that's not too bad, I guess. So what I'm attempting to do here is we're going to see which one of these is, which one of the strings compare is faster. So let's put some comments in here. Start time. And then we will start another clock for basic comparison. We'll make it print the exact same thing. Make this run off start too. So this should compare to see which one's faster. I actually don't remember which one is faster. So it looks like string.compare is a little bit faster in this case. Now if we put some big, huge, long string in here, maybe it'll show a little more discrepancy. Yeah, it's about the same. So, and I just stated that incorrectly, actually. Someone just called me out on that. The string compare took longer than just a basic equality compare. So I use string compare a lot because there's a lot of extra power that you can add to it. But if it is just kind of a basic, and also the strings compare is doing a strings to lower. So to make it fair, I should do the same thing with this one. That would explain the huge discrepancy there. Yeah, string compare is still quite a bit slower, but it offers a lot more power, so don't avoid using it for performance purposes if you need it for anything kind of crazy. Let's see, what did I have next on my notes here? Ah, yes, searching strings. So we'll wipe all of this out, and I'll show you how easy it is to search strings with the strings library. We no longer need time. We no longer need my commented out strings there. So now we'll say, let's see. Sample string is so what we can do here is just do if string contains something. So the way I generally do it is create a new bool. Strings contains, and it's going to be sample string first. I always get this parameter order mixed up. And then what we're searching for. So we're going to search for the word great. So if we find great, we'll say this. We found it. The word great is in there. What about the word turtle? I love these super basic explanations for stuff. No match. So it really is that easy. Just strings.contains. There's some more powerful things you can do with this, of course, but if your string contains something, I usually push it off into a bool and then just use that bool later. You can do all kinds of crazy logic and stuff with that. So that's how easy it is to search strings. You can do this with Regex also. Let's do a new sample string. I'm not a Regex expert. I generally have to look up Regex pretty much every time I use it because I only use it a couple times a year, it seems like. There was a time when I worked with Regex all the time, pretty constantly, and I started to get really good at it, and that was years ago, and I forgot it all. So yes, I'm one of those people that programmers like to talk down to for having to look up Regex every time, but it's who I am. it's fine. Now, here's a sample I used in my course. This is a string. There are many strings like it. This one is mine. So if we want to look for this, we need to do a Regexp. So I need to add Regex library to it. So for our regex, we will create regexp.compile. So what you have to do is compile the expression string, and then you can use it and run it against this string or multiple strings. So for this one, let's say we're looking for a string that starts with S. We want to look for an entire word, A through Z. And we want it to end with a G. So let's see if this one works. I believe this is going to be the string that I would like. Here's our expression. This is one of the reasons I don't like IDEs, because they put stuff like this. Like, I know it's an expression, it kind of gets in the way. So now we have this R object that we can do all kinds of cool stuff with. So let's see if we have a match here based on this regex. We'll do print line and R match string. So what this does is basically we're calling this compiled regex expression, and then we're going to pass in sample string to it. So we're going to see if anything in sample string has a word that starts with S and ends with G. We should have one. Oops. So we'll go ahead and comment this out. True. We do have one. Cool. We can find all instances of it. So let's say, like if we have 2, it's just going to say true. Yes, we have one. Maybe we have 1. Maybe we have 10. Who knows? So this one will be find all string. There it is. Ah, yes. Where do we want to start? Right there. 2. We have 2 of them. Now if we change this to song, it's still going to match that regular expression because it starts with an S and ends with a G. True, we found song and song. So, let's see, where are they at? You can also find that here. R dot. Find all index. Find string index. That's what I'm looking for. Simp string. So I think it's, there we go. There we go. We've got it at 10 and 14. So that's this guy here and this one over here. What else can we do? Oh, we could do a replace all string. So we'll replace all words. This is a string. What can we replace this with? Line R dot. Let's replace all string. And we want to replace everything in sample string that matches that description, so starts with an S, ends with a G, and replace that with apple. This is an apple. There are many strings like it, but this apple is mine. So notice when I remove that /b there, now it's going to replace this whether it's a whole word or not. So if I use /b, then it's going to be a whole word. Clear it so. And it replaces string, the whole word, with apple. It does not replace strings because that has an S on it. And then it replaces this string with apple. But if we remove this little /b, then anywhere, any stream of characters that starts with S and ends with G will be replaced with apple. Pretty cool, right? So it's a pretty powerful library. It's pretty awesome. Another thing I was going to show is how easy it is to trim strings. So we'll get rid of Regexp, and we will add in strings. And for the trim string, I used an example, I believe like this. One with a whole bunch of wacky space on it. Okay, so I have a sample string with a bunch of white space on the back of it. Now, if you just do a print of sample string, let's say do a print line, you probably won't even notice it. Oh, strings was not used. Comment you out real quick. All right, so there are some trailing spaces on here, but you can't really tell. This is one of the reasons I like printf so much. Now instead of print line, we'll do %q. This will quote the entire string so that we can see what's really in it. And as you can see here, I forgot my carriage return. So let's start over again while I show this. So if we just do a regular print line of sample string, and this one, here, this looks perfectly fine. And I'm getting a phone call. So if we look at this string here, it just kind of looks like any other string. But if we throw the quotes around it with that %q as a part of printf, then we can see, oh no, we've got a bunch of white space at the end. So how are we going to fix that? We're going to use the strings library. And we're going to trim it. So we can actually leave this one just as it is. And we can just trim it. Okay, I will be right back. All right, we are back. Oh, I forgot what I'm going to be trimming off of here. Okay, so if we look at this here, we've got printf, and I'm using it in the using this format identifier as quoted, so it quotes it. And then we're just saying trim right, and we would just want to trim spaces off of it. Pretty cool, right? So just to show this a little bit better, we'll do a little before and after here. Trimming white space is one of those things that you just do all the time. And as you might imagine, trim left works the same way, only on the left-hand side. And you can get pretty custom with these things too, but so here's the original string. Here's after we trimmed right. Here's after we trimmed left. So we could do, in this particular case, trim space. And then we don't need to pass in that space. Since white space is a pretty common thing, there's our neat string. Ta-da! I'm just going to do that every time something that I think is cool is on here. So trim space is probably the most common, but trim right and left, use it all the time. Suffixes is another cool thing. I will put that one on there. Let's see. Sample string. You can do prefixes and suffixes on here. And this is another handy thing. Look at me. I'm always finding a different way to plug my website. I'm telling you, shameless promoter. So here, what is it? Domain name. We'll call it domain name. And we'll just do strings, trim prefix. And I always forget the order of this one too, but I believe it's this one. And then whatever the prefix is going to be that we want to trim. In this case, HTTPS. So theoretically, string. Very cool, right? So you can trim off prefixes. You could even do it like this. My website is jeremymorgan.com. Suffixes work the same way. Let's see. Document.doc. I don't think there is actually a .doc prefix anymore. I think it's all docx, but whatever. Again, very cool stuff. So you can trim suffixes, prefixes, things like that. Great for, say, email addresses, whatever. Web addresses, that's kind of a good way to make like a friendly display name. So if you have a big, huge list of websites, you can chop off the HTTP or HTTPS from any of those. Oh, what else can I show here? The string library. Oh, I was going to also show how easy it is to parse CSVs And then we'll open up a CSV file. Let's make sure I still have it here. Yeah, so I got this fake data here. And so I just generated some fake data here, and I'll call it fake data.csv. And we're going to open this up and parse these values. As you can see, we have an ID, first name, last name, email address, gender, IP address, and then I added a buzzword on the end of it. So for this, we probably will use strings, so I'll just kind of comment that out. And we need to import buff.io. So I'm going to use a buff.io scanner to read this. We're going to need OS to open the file. And that should be all we need for now. So first we'll open up the file here. Use os.open. fakedata.csv. It would help if I formatted that properly. So this opens up our fakedata.csv. I'm not going to do any error checking on here or anything, but you of course would want to in a real application. Create a new scanner here, and this is going to be buff.io new scanner. And that new scanner is going to be off the file reader that I just created here. So open the file, load into a scanner. Now, one of the cool reasons you want to use Go to read a CSV file is Go is extremely fast. I've used Python to read CSV files for years and years and years, and I can't say that Go is incredibly faster than Python, especially if you're doing it on a single user basis. However, if you are dealing with big, large amounts of data, you want to open up multiple channels, anything crazy like that, Go works fantastic for this. This is only a 1,000-line CSV file, but it'll just rip through it like it's nothing. So we'll say for. So while our scanner is open, we are going to take the scanner text into a line. And this just basically, so the scanner, when it scans, will go through this file line by line, and it uses a carriage return as a delimiter. So it will, as we do the scanner line.line, it just, well, why don't we just show it? This should work, I believe. There we go. So if we do println, there we go, line by line. So it does the exact same thing, incidentally, as cat. So this is basically a cat program right here. But we want to do something a little bit more with this. So we're going to display it. Yeah, let's go ahead and split it and display it into something a little cooler. So we'll do print line, and I'll just put some kind of delimiters here. Oops. To show that we're opening up a new record. Let's see. I don't know what to call them, so items should work. Now we can do strings. Dot split. Not split after, just strings dot split. And we want to split line, which we know is our line of text, and we just want to split it by a comma separator. So now we've got this neat little slice of items here. So probably the easiest way is to just do a range of these. And format print line items, and then we'll use this as an index. This should work. All right, let's see what this looks like. Ta-da! Again, I'm going to quit saying ta-da. Start using ta-da. So now we're reading in this CSV file. Pretty awesome. We can let's change this up a little bit. Let's see what our indexes look like. Printf, and we're going to say string. It's going to be I. And items I. Let's see what that looks like. Yeah, we'll do. And now we've got a little index here for some of them. There we go. Now that's work. Pretty sweet. So instead of just going through the range, we can actually do specific formatting on specific items in that string. So we know the first one's an ID, so we can say empty print line. We'll do printf. Let's see, ID equals actually, we'll still use that for loop. This will make it. Let's see. Instead of this, let's see. I think this will work. Just our IDs. And it likes to be a string. We'll make it a string. So there's our ID. What I'll do is go all the way back up here. Okay, we'll use this again. This is what I was going to do a minute ago, and I should have. We'll make ourselves a little key here. So a lot of times when I'm coding, I like to just kind of put a format in like this. And that keeps a sample of the data with their indexes, so I just kind of know what's what. Okay, cool. So now we'll print out our ID. Name. Printf is excellent. The printf, it's similar to printf in C or other languages you've used. And it's just awesome when you're doing command line stuff like this. So now we've got our first and last name here. We're going to print out the email address. Now, oftentimes when I'm using printf, I forget to throw that little new line in there. That's pretty helpful. Now we've got an email address. And these all just come out as strings through this line. Just present this. All right, so this should be, this looks a little better. There we go. Now we have everything formatted kind of nicely. Let's make a title here. So we'll go strings dot title. And we'll make it title case for their favorite buzzword or phrase. Simple and easy. So what's another thing we could do? What if we wanted to like get the first part of their email address? How would we do that? Here we can use strings, trim right, as you remember before. Now instead of trimming, we trimmed spaces before, now we'll trim right from the @ sign. And I think this will work. It did not. Okay, let me try this again. Trim right. Do I need to return a value? Three strings. Yeah, this absolutely should work. Let's see what I'm doing wrong here. Right. So string is going to be items 3. Yeah, it should work. And it did not. So I'll have to investigate why that does not work. Even with the %v. We can do several things to each of these each of these elements. And yeah, it's really this easy to open up and parse a CSV file like our fake data CSV. You could put a counter in here if you did not have, let's see, if you did not have an index, you could say zero. Oh, that's right, we're out of scope. We have 1,000 of them. So I need to set my counter to 1. So this is opening up a CSV file. Yeah, I don't see anything in the chat room. So this is just kind of the beginning of what I will do with our string library. I think I'm going to do a few more of these streams, just kind of showing some basic stuff. I'm totally open for requests on anything anybody wants to do. If there's something particular you'd like to see with strings, some more search functionality, I don't know, something kind of cool like that, let me know. So I think I'm going to wrap this up, and I'm going to do some more cool Golang stuff. One of the things I want to do in a future stream is build a web API with Golang with just a standard library, and we'll see how easy that is to put together. We'll put that together, and then I'll push it off to some server somewhere. We'll push it off to a function. I don't know yet, but like I said, I'll be taking requests for this kind of stuff. I'm going to do some streaming during the week, during the daytime when people are at work. Friday night just happens to be super convenient for me, but it's not exactly convenient for everybody. So I am going to do some streams during the daytime, in the morning, things like that. And go ahead and hit me up on Twitter, LinkedIn, wherever it is that you generally contact me if you want requests for anything cool that we want to do in Go. For the very, very near future, there's going to be some computer vision stuff that I want to kind of work on and display, and then a whole bunch of Go stuff. As I said, I'm doing a talk for the Go West conference. Let's bring this up really quick. So I kind of want to plug that. Go West Conf. There we go. So this thing's pretty cool. They've got a hackathon coming up here. September 1st, October 1st. Coding for prizes, all this kind of cool stuff. And then the show, October 2nd. Let's take a look at some of the cool stuff here. This is free, by the way. This is a free virtual conference. There's going to be a lot of really cool stuff here. I'm super excited. I'm actually going to most likely take a day PTO or two to like kind of watch through and go through these things. I've been doing so much Go stuff lately, and they all look exciting. But like building a game engine, writing REST services for the gRPC Curious, that one I almost feel like I have to attend that one. Functional programming with Go, working from home, getting started in Go, which is going to be pretty cool. The standard library bootcamp, that's the one that I'm going to be doing. So don't miss that one, right? But going serverless, I think would be pretty awesome. All types of Golang types. This one, Golang types are pretty interesting, and the more I've studied into it, I realize that's probably going to be a very long talk that's condensed down quite a bit. So the binary analysis of Go is going to be super interesting. That one I'm definitely going to check out because it's so far outside of anything I know about Go right now that I think it's going to be pretty cool. Women in Technology meeting here, kind of a meet and greet. Go without generics, and then micro machine learning in Go, and so you think you know Go. This one's another one that I feel like I don't want to miss. So you think you know Go. I don't think I know Go super well as an expert. I mean, I'm pretty good with it. I've built stuff with it. I can definitely sit down and build stuff, but I have a feeling that this particular one is probably going to be a little bit of an eye-opener. So this one is Corey Lanau. I'm not sure how to pronounce it. Says, if you've worked for Go for 2 or 3 years, you probably think you know Go pretty well. That speaks directly to me. I've been working with Go for a couple years. Let's test that theory as we talk through the aha and gotcha moments of every Go developer should know. So this one I think is going to be great. So if you don't attend mine, that's fine, but you should probably attend this one. And probably functional programming with Go is another one that's going to be huge. So anyway, this is the Go West Conf here. It's free. Tickets are still available. They're going really fast. They just announced everything today, so it might be full if you don't sign up and jump on it now. Thank you, everybody, for attending my little stream here. This wasn't very well prepared. I just basically had a note here, like a notepad that said change casing, better title casing, string comparison, searching strings, regexing strings, trimming strings, splitting up a CSV. And those are the things I decided to show. We showed that, and I'll be doing more cool stuff. I want to try to find some awesome demos because, I mean, Go isn't like the most exciting thing in the world sometimes when it comes to demos. So when you're doing demos, I have seen some really cool, weird things that people have done with Go, but it is hard to make cool demos. I promise you this Go Standard Library Bootcamp, I am going to strive to make the most coolest demos I can to show off some of that stuff. So let's hope I can pull it off. But when I start doing computer vision stuff, I'm going to try to figure out how to do computer vision in Go. So that'll be a little more exciting. Yeah, I'm going to keep doing these streams and teaching people. For people who want to learn Go, Go is super easy, super intuitive, especially if you're coming from another language like C, C++, Python, any of the languages out there really. There are similarities to C-based languages, and it's very cool. It's a very fast system language. So I'm going to be doing more of these and kind of showing it off. Anyway, thank you very much for attending, and I will be back most likely next Friday. Next week, I'm trying to cobble together a couple of cool streams to do during the daytime, and I'm just going to keep doing this from my little streaming office here. So thanks for joining me. I'll be back on soon, and I really appreciate it.